Okay, lesson 62, classifying triangles. Do you guys ever classify things in science class? Like they have class, kingdom, phylum, or something like that. They have all these. Like animals.
I know what they are, it's just we don't learn them in science.
Oh, you don't learn them in science this year? I think you will at least in 9th grade, because my 9th grader is. There's a species, and there's a class. Order. Okay. Anyway, we can sort triangles. It's like sorting. 2 different ways. So we're going to have 2 columns here. So if we are classifying by angles, that means we just look at the angles of the triangle. So we first look at or find the largest angle. So just look for the biggest angle in the triangle. If it is more than 90 degrees, so if you look at this, the biggest angle is obtuse. So this is an obtuse triangle. If the biggest angle is 90 degrees, it's called a right triangle. And then if the biggest angle is an acute angle or less than 90 degrees, it will be an acute triangle. So that's by angles. Then we can classify them by sides. So when you're classifying by sides, it depends on how many sides match lengths. So if you have none that match, that's called scalene. So if all 3 sides have different lengths, it's scalene. If you have 2 sides that match or have the same size, it's called isosceles. And by the way, the definition of isosceles is 2 or more sides are congruent. So if you have 2, if you have 3 sides congruent, it's isosceles. But we normally call all 3 sides matching. So if all 3 sides match, we want to call it equilateral. So even though it is also isosceles, we call it equilateral, okay? So if all 3 sides are the same length, it's equilateral. 2 sides, isosceles. No sides, scalene. And then if you're doing by angles, we have obtuse, right, and acute. In a triangle, there is one side opposite each angle. So if you have triangle ABC, across from angle C is segment AB. So I want you guys to put your hands like an angle. Okay? So we're going to pause for a minute. Put your hands like an angle. Do you see the imaginary line between your fingertips to make a triangle? Okay? The angle that's made by your wrists, the side opposite is the imaginary one that's between your fingertips. Okay? So every angle has one side that's opposite from it. So angle B, the side opposite, so imagine if these were your wrists right here at B, is this imaginary line when you're just holding your hands up. It would be AC. Okay? Or you can think about it if you're looking at angle C, the opposite side are the other two letters, AB. The opposite to B is AC, and the opposite side of A is BC. The largest side is always across from the largest angle. So if you imagine when you are making an angle with your hands, the bigger the angle, the longer that length between your fingertips. So the longest side of any triangle is always the opposite side of the largest angle. And then the smallest side is always across from the smallest angle. Then we have the Isosceles triangle theorem, which you guys don't have to remember what it's called, but if you have an isosceles triangle, that means two sides are congruent. And the theorem states if two sides of a triangle are equal, I'm going to say congruent. I'm going to change that word equal to congruent. Do you guys know the congruent symbol? What that means? Have we talked about it? It means their lengths are equal. Congruent means they're the same size. So if you just put a little arrow there and say lengths are equal, that's what congruent means. They're the same length. Then the angles opposite those sides are congruent. Again, that means the same size. So that's why I put the little arc marks to show that this side, the angle opposite, will be congruent to the angle opposite, the side that has the same length. So if you put your hands at a certain angle, the side, it's going to be a certain length between your fingertips, right? If you have another angle the exact same size, that length is still going to be the same distance. So that's the end of the lesson, and we're going to do some practice.